topic 11, another geometry topic, which you guys seem to like. And our learning goal today, student will understand radius and diameter of a circle. Have you guys heard of those terms before? Yes? Do you know what they mean? So we've heard of them, we just don't know what they mean, which is cool. Okay. All right. So next slide is going to kind of tell you what they are. So I've left this up here. I think it's so silly that they tell you what a circle is, because if you don't know what a circle is by this point in time, I'm not sure how much I can help you. A circle is round, okay? Circles are made up of millions of points, and they're all the same distance from a center, which means circles are not ovals. They're circles. They're perfect circles, okay? And then a lot of times they'll put a center point like this where it says P, and so they'll call this circle P because they put a dot in the exact center and called it P, and that's how they'll name it. Okay, then a diameter is basically a line segment that goes all the way across. So diameter is perfect across the center of the circle. And then they're going to say this is a segment because lines go on forever, segments stop. So that's why they're calling it a segment. Okay, then we have a radius. And a radius is just halfway across the circle. So they start in the middle, they go out to the edge. That is a radius. Sometimes you're going to see it be said radii. So one is plural, one is singular, but you can hear it radii or radius. That's it. Across or half. All right. Okay, you can name these segments by their endpoints. So just like when we were naming angles, you can name line segments. And the way that you read AB, so right here, if I want to go from here to here, then I would say that this is line segment AB. But mathematicians don't like to have to write things out. They love to abbreviate things. So I would abbreviate this by saying AB, and I would put a line over it. And that would mean line segment AB. Just like last chapter, we talked about angles, and we would say angle, say this is ABC. That would be the angle. That would be the line. Does that make sense? And so they're going to put that. So it says that they're going to show AB, BC, and AC all on this diagram. Is A to B a radius or a diameter?
What diameter?
Sure. Radius. You sure? Okay, so now look at the difference. Okay, you guys all see A to B, right? Look back at this. This is a diameter. This is a radius. What do you notice is different about A to B? It doesn't go through the middle, so it's neither. That was a trick question. It's not a radius or a diameter. It has to go through the middle to be one of those. Okay, diameter all the way across, radius halfway across, has to go through the middle. Okay, all right, the next thing they can do is they'll like to tell you, so not only can I say something is a line segment, so again, if I say A to C is a line segment, I do it like that. If I want to say how long it is, then I can put the measure, and so they'll do it like this. So they'll say A to B is 3 inches, and that's how they'll write it, or A to C is 3 inches, and that's how they'll show you how long something is. Okay, because we're going to be building a lot of shapes during this unit. Oops. All right, so now this is exactly what I was just going over. You're going to have to be able to pick out the difference. See here they put radii, okay, and then diameters. So an art class developed this logo to represent the school in an art show. Determine which segments are radii and which segments are diameters. Okay, so I would like you to start with, so we're all on the same page here. Start with PD and tell me, do you think that's a radius or a diameter?
Radius.
Radius. So P to D is located right here. It goes from the center to the outside, so that is a radii. Good. Radius. All right, let's try AB. Neither. Why are you saying neither? It doesn't go through the middle. Very good. So AB is not one. Very good. All right, let's do a C. Diameter, good. Here's AC. It goes through the middle. So diameter would be segment AC. All right, let's try B or PB. Good. Here's PB. It goes from the center out to the edge, so that's a radius here. PB. All right. What about AP? AP? AP. It's radius. Yeah. Here's A to P, right there. So that is back to this. AP. All right. What about AD? Neither. Good, because it's not going through the center. So no, that is not either one. And our last one is PC. Yeah, very good, because it's right here, P to C. That would be a radii. So PC. That one works there. Okay? Good. All right, I would like you to take a look at this one and answer this one on your own to see if you understand what we just did. All right, raise your hand if you can tell me how many radii are shown. Demario, you said 1? You said 4. Okay? Agree? Disagree? Micaiah? You agree? Kendall? You agree? All right, so all I have to do is look at the center right here at O, and this would be 1 here. This would be another, so that's 2. This would be another, that's 3. This would be another, that's 4. So there should be 4 different radii. All right, moving on. All right, so this says 2 radii of a circle that lie on the same line form a diameter. So does that make sense? It takes 2 halves to make a whole. It takes this one plus this one, and then that, of course, makes the whole diameter. Okay? So the length of the diameter is twice the length of the radius. Does that make sense? To get the diameter, you take 2 times whatever the radius is. Okay? All right, so let's look at this next example. The center from a car to the center of the Ferris wheel is approximately 221.5 feet. Approximately how tall is the Ferris wheel? Okay, so they're saying from a car to the center. So let's pick a car here to the center. That would be a radii. And it says it's 221.5 feet. How are we going to figure out how tall the Ferris wheel is? Sam? Very good. Times 2, because that's our formula right here. All we have to do is multiply it by 2. So 2 times 221.5. So what is that going to be? 443 feet would be how tall it is. Does that make sense? It's really kind of simple, I think. Does it seem simple? Because sometimes when I think things are simple, you guys say, no, this is hard. Okay. All right. So I'd like you to try this one on your own. Zeke, what do you think? Exactly. You're going to divide 4 1/3 by 2. Because this says the diagram here is S to T. So this whole thing is 4 1/3. And I only want from S to O, which is right here, S to O. So I need half of that. So how do I take 4 1/3 and divide by 2? How do I do that, Kathy?
Okay, first you need to change 4 over 4 and 1/3 to the f of the fraction.
Good.
Put a 1 over the 2.
Yes. So I take 4 times 3 is 12, add the 1, and that's 13 over 3. Divided by 2 over 1. Now what do I do? Nope. Not yet. Remember how to divide fractions. Kathy?
Flip the equation so that, flip the 2 over fraction so that it'll be times the multiplication.
So 13 over 3 times what?
1
1 over
over 2.
2. This is that keep, change, flip. Where you keep the same one, change the multiplication, flip the last one to its reciprocal. All right, so now I can multiply straight across. So 13 times 1 is 13. 3 times 2 is 6. And then I say, how many times does 6 go into 13? 2 full times with how many left over? So 1/6. Now, does that make sense? If this whole thing is 4, does it make sense that half of it is 2 and something? Yeah, that should make sense. And if you have a third, half of a third is a 6. Okay? All right. How did I get 2? Because 6 goes into 13 2 whole times. That would be 12. How did I get 2 where? Up here? Because I'm dividing it by 2. Because this is S to T, and I just need S to O. I just need half of it. You could also multiply this by a half. That would get you that answer too. All right, let's mix this up with some algebra now. All right, so the expression 13x minus 1 represents the diameter of the orange slice. What is the value of x? What do you think about that one? Okay, so are you saying I need to figure out what the diameter is? And you just double 2.5? Sure. So this is talking about the diameter right here. I don't know what the diameter is, but I know the radius is 2.5. So I need to double that. So how much does that make it? 5. So the diameter is 5. Okay? Now what do I do? Perfect. Set up an equation. So it says the expression 3x minus 1. So this whole thing is 3x minus 1, but we also know that it is 5. So 3x minus 1 equals 5. And we are very, very good at solving equations now. So all we have to do is add 1, and we get 3x equals 6. And divide both sides by 3, and we get x equals 2. Questions on that one before we keep going? Does that make sense? Yeah? Doesn't seem too bad? All right. This one says if Km equals 2x minus 4, so if I go to the diagram, here's K to N, and that equals 2x minus 4. And it says L to M equals 12. So here's L to M equals 12. What is the value of x? What should I do first? Okay, so she thinks it's 2x minus 4 equals 12. What do you guys think? And you think it's 2x minus 4 equals 24. What do you think? Kendall? You agree with him? Okay, so remember, K to M I wrote in blue. And this equation goes with the blue. The red here is only the 12, which means we need this 2, and 12 and 12 would make it 24. So it's actually the diameter. So we're going to say 2x minus 4 equals the whole line, which is 24. Okay, and then again, we are really good at this. We just have to add 4 to both sides. So now I get 2x equals 28, and then divide both sides by 2, so that x equals 14. Okay, all right, is there anything on here you don't get that you need my help with? Does it make sense? All right.